All right. My name is Aaron Schlesinger. If you can pronounce that, I have Athens stickers, so you can come repeat that to me and I'll give you some stickers. So I work on Windows 95 at Microsoft. It's written in Go. Fun fact. This might be the most fun I've had at a conference in a long time, so thank you all. So I'm a cloud advocate at Microsoft, core maintainer on the Go on the Athens Project. This is our logo. And I'm going to start it off with a super, super hot take. Maybe this isn't a hot take for you, but it is to me, and I've heard this from other folks. I don't believe we've had proper package management in Go ever, honestly. We've had really awesome tools for package management. But if we look over to some of the other kind of big-ish languages in the programming community, they tend to do a little bit better of a job. But that's changing. And Athens is not the solution to it. It's part of the solution. But you can probably guess I'm up here talking about modules and module proxies. And modules are a massive part of the solution to package management that we're getting. We have now, and we're getting more of it in Go. So we had, I think, a talk earlier by Julie that talked about, is it Julie? Is that the right name, I think? Julie? Yeah, OK. So she talked about modules. She talked about sort of the definition of a module. I'm shallow, so I'm going to talk about sort of the cool bells and whistles around modules. Basically, I can still use go-get. I don't have to learn another tool. I don't have to use the go path anymore. Who loves the go path? Not me. OK, so there's two people. Who is excited about not having to use the go path? OK, yeah, go path. OK. And how about the vendor directory? Who loves the vendor directory? I would assume the room will be split. Oh, wow. OK. Well, you can get rid of the vendor directory, too. And both are optional, by the way. I am personally very excited about being able to do those things. But you don't have to. And that's my introduction to modules. That is all you need to know. Don't worry about reading any of the documentation. I'm an expert. But seriously, that short link will take you to the official Golang wiki on GitHub, and it's got everything you need to know about modules under the sun. So super recommend you go and check that out. These slides will be up, so if you can't remember FN, you can click on that in the slides as well. So that being said, that will be all you actually do need to know about modules for this talk, because I'm going to go into more how do you get code for the modules ecosystem onto your machine. So we all know go-get. Even before modules, go-get would go up and get code from the VCS, the version control system that package at the time corresponded to. So you might have github.com/whoever/package name. Or you might have gitlab.com/whoever/package name, and so on and so forth. And this was pretty awesome. And it really is still pretty awesome. Because if you see a package name, you kind of know exactly where to go in the common case to look at the code. And also, if you go to godoc.org, you know exactly where to go to check out the documentation. So although I put a hot take out there and I said we haven't had proper package management, this really has worked super awesome for us for 8+ years. So I don't want to disparage that. And I want to be really clear that this is kind of awesome. And of course, we've built tools on top of this. We've built things like dep and glide and the other big group of all these awesome dependency management tools that all work on top of this concept of pulling code down from the VCS. But, here it is, but we've had some issues with this. And as time goes on, entropy has come into play, Murphy's Law. When people go, if you're a package maintainer, and you do like a force push, you change the code at a single commit, or you delete a tag, or worse yet, you delete a repository, or even worse than that is you change owners of the code. In the best case, if something happens, your build will break. Of course, unless you have it vendored, and then if something happens, you're responsible for the code now. But in the best case, if you don't have it vendored, your build will break because someone, maybe they changed a exported method or something like that. But in the worst case, you'll still build, but you'll have different code. So instead of hashing a password, now someone will email all the passwords or the credit cards to you or to them. Okay, so that's not amazing. Modules helps fix that. But another piece of modules that helps fix this problem is now we have a non-VCS API that helps us get code from somewhere, no longer the VCS, but from somewhere that implements this download protocol down onto our machine. This is an HTTP API. This is I think this is actually all of the endpoints in the module API. And now that we have an HTTP API, we can sort of separate ourselves from the source code that goes into a module from the actual code that goes down onto someone's machine. I call this the module asset, or the dependency asset, and the development code, the code that's currently being developed in the VCS. OK, so we've got an HTTP API. This is independent from the GitHub API or the GitLab API or anything like that. It's specific to Go. Super awesome. What can we do with that? OK, well, obviously, we have this HTTP API, so we can take advantage of some web conventions, some internet conventions. So the first thing that I could think of is we can put this stuff behind a CDN, a content delivery network. Okay? So we can somehow fill the CDN with code from the same places that we had before: GitHub, Bitbucket, GitLab, any other VCS server, maybe your internal VCS server, maybe a vanity domain, whatever it might be. We can take that stuff, put it into the CDN, have the CDN expose the correct endpoints for the module API, and now all of a sudden we can point go get to our CDN. So that's pretty cool. Now we've got this separation going. And not only do we have the separation going, but we haven't really changed the workflows for either the package maintainer or the person who depends on that package. So the package maintainer, if we do this thing right, the package maintainer can still do git push, and they can still tag and merge pull requests and so on. And the person writing their app that depends on that package, they still just do go get. Now they might have to do a little bit to toggle go get to point to the CDN now, but other than that, it's kind of just the same thing. So that is where we want to be. OK, that would be amazing. How are we going to get there, though? OK. So we've got this technology in place, mostly. We'll get into how we actually make it happen like completely in detail in a second. But now this kind of raises the question. We've got the technology. How are we going to actually get it out to the community? So there's kind of two aspects here, two vectors we're going to follow to make sure this thing will work. So we need to make this thing reliable. Most CDNs are pretty reliable. You put the code up there, it's static. CDNs push it out to the edge, it's super fast. That's awesome. But it also needs to be discoverable. So that's kind of the part that we need to tackle here. So when you think of discoverability, you might think of a central registry. Or in other words, you might think of a URL baked into the Go tool that you will always use. Now, there will be, I believe, a URL that is baked into the Go tool. However, you don't need to always use it. And this is the key point. We're going to be talking about federation throughout this whole talk. And that is an important point for this whole thing about module APIs. So there will be a registry, so to speak, that is out there that when you do a go get, you can get code from that registry. But there also will be options for you to get code, including your own private code, from somewhere else. So I actually don't like to use the term registry because, has anyone heard of left pad or pad left, as Julie put it? Has anyone worked in JavaScript or Node.js? Can you raise your hand if you have? Has anyone gotten their builds broken before by left pad? OK. Well, if you don't know, if you're not familiar, the NPM organization that ran and still runs the JavaScript central registry was compelled to take this tiny little piece of code. I guess it was 11 lines of code. They were compelled legally to take it down from their registry. And it just so happened, to everyone's chagrin, that it was at the bottom of the dependency tree for all these massive projects, like React, for example. So everyone who used React, who didn't vendor their code, which was quite a few people, they just checked in their code one day and CI ran, and then boom, broken. So that's a problem that is not really a technical problem. It's more of sort of a community / maybe sociological problem. So we don't want people in the community, at least I don't want people in the community, to start relying on this sort of NPM-like central registry. That's OK, but it's nice to have other options. And that's kind of where Athens comes in. So Athens is by no means a replacement for a central repository or a central proxy. It's just another option that encourages federation of all these things. So Athens implements something similar to what we saw in that CDN diagram. Okay, so Athens is the thing that sits between the VCS and you, the person doing a go get. But it also has storage. And the storage is the key piece here. Because when Athens gets a go get request coming into it, if it doesn't have it in storage, it'll go grab it from the VCS and it'll put it in storage. And then from that point on, the code for that module in storage will never change. It's immutable. And so that's what gets you that reliability. That's what gets you the sort of protection from someone accidentally or purposefully deleting a module from the VCS, or someone taking ownership, transferring ownership for that module, and putting in that little line of code that emails hacksaw@gmail.com all of your passwords or credit card numbers. So you control the code that's in your storage that Athens maintains. And that's really key because not only do you control the code, for example, if you've got internal code, private code, but also, again, it encourages you, if you want to, you can run your own Athens. And we'll get into this in a second. But not only can you run your own Athens, you can also run a mirror of public code. You can point Athens up to another sort of central-ish repository or proxy if you want. You can point Athens to another Athens. Or you can point Athens to a separate implementation of the module API. And vice versa. Everything can sort of talk to everything else. Did I mention federation yet? Have I said that word enough times to get, yeah? Okay. Okay, so enough of my blabbing. We're actually going to go into a demo. We're going to show building Hugo. Are people familiar with Hugo? If Steve was here, I would call him out because he built the first version of Hugo. So for those who don't, Hugo is a static site generator. We use it for building the documentation site for Athens. Tons of other folks use Hugo to do various different things. But I'm not really going to show Hugo in action. I'm going to point out that Hugo is a real big project that has a bunch of dependencies. And we're going to show building Hugo from 3 different types of Athens servers. OK, so I am going to first make this bigger. Bigger, 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 bigger. Can anyone in the back not see this? Raise your hand if you can't see it. Awesome. Was that a yes, me? OK. And I'm going to not show this, and instead show this. So I've got a little sort of demo script. The first thing I'm going to do is easy. So I have a checked out version of Hugo that's just from the canonical Hugo repository, not a fork, nothing like that. And I just want to build Hugo from an Athens that I deployed in the cloud somewhere. So this is an Athens in the cloud that has some backing storage. It's stored these modules already. It's not going to be going to talk to GitHub or anything like that, any VCS at all. It's just going to serve up the dependencies of Hugo directly to me, doing a go get. So first things first, how do I configure my go get to go talk to this thing in the cloud? There's a new environment variable called GoProxy. This is the thing that will tell go get, hey, don't go get stuff from the VCS anymore. I want you to go get stuff exclusively from this server. And of course, it's an environment variable, so you set it to whatever you want. I believe in 1.13, or maybe one of the Go core team can probably confirm or deny this. But it might be 1.13, it might be later. This will be defaulted, but you can always change it, of course, if there's a use case for you to do so. So I've changed it to the one that I deployed in the cloud. You can use this too, but I charge 50 cents per millisecond for support. So just keep that in mind. My Venmo is open. OK, so 2 other pieces here. We have a local disk cache that Go modules uses by default. Right, so there's nothing really faster than disk if you're talking about disk versus going over the network, which I will be doing via conference Wi-Fi, so cross your fingers. So the first things first is we're going to actually go and delete that local disk cache. So the disk cache is get gopath/pkg/mod. Put in my super secret password here. And then I think I built Hugo before, so we're going to delete that. Oh, I guess I didn't. OK. So now the super exciting Go build. So sometimes I say this is both the most boring demo you'll ever see and also the most exciting one, depending on how you look at it. So I'm going to run Go build. Now this is new output if you've seen Go build before modules. Who has done a Go build before 1.11? Yeah, OK, yeah. I feel like you should probably all raise your hands. You're at a Go conference, but it's OK. It's OK. All right, so we're doing a Go build. This is new output for modules, OK? So we've got a bunch of finding. So this is really, these are all of the dependencies of Hugo. Finding, when you see that, it means Go build is going up to that Athens server and asking for a bunch of metadata about these modules. Now it gets the metadata, and then we switch to downloading and extracting. So downloading is what it sounds like. We're downloading code onto our machine. And then we're downloading archives of the code, so we start extracting it. So these are all the modules that we're actually getting onto our machine and filling up that local disk cache. And now we've got to build Hugo. Let's just show that in action. Cool. All right, so then now we've got code in our pkg/mod. And this looks a little bit like the old GoPath/src directory. And it kind of is, and it kind of isn't. I'm not going to go into that completely today. But if you turn on modules, do your Go build, and these instructions are on GitHub, and I'll put a link for that later, you can actually ls into this, and you can see the structure that looks really, really, really similar to what GoPath/src used to look like. OK, that's the first build of Hugo. The second one is I'm going to run my own Athens. And I'm going to run it in Docker. You don't have to do it this way, but this is the easiest for me over conference demo time. And this is me running Athens in Docker. I'm exposing port 3000, which is the default Athens port. I'm turning on debug logging there with that environment variable. And I'm running beta 2 with a bug fix. This is our patch release of 0.3.1. OK, so nothing super special here. This is a public image. You can go check out these instructions, pull down the public image, no biggie. OK, so before I was pointing my Go build to the public one on the internet. Now I'm going to point my Go build to the local one. Localhost 3000. OK, no biggie. Let's go and delete our cache. Because cache invalidation is a thing that's hard, but not this time. OK, so recap. We're pointing our thing now, our Go build now, to the local one. Let's see that happen. So this, instead of pulling down like a little less than 100 megabytes, I think now we're going to pull like almost 500 megabytes. So cross your fingers for conference Wi-Fi here. You have them crossed? All right, let's do it. OK, so finding again. Same deal, except we're going to the local Athens now, the one that's in that other browser tab. So let's check it out. All right, so we've got a bunch of requests for .info and .mod. These are those metadata endpoints I was talking about. OK, so a bunch of requests, down, down, down. Well, we're just going to hand wave over that error real quick. Conference Wi-Fi. OK, so we're still going, we're still going. Error loading module requirements. Let's try this again. Whoops. We're going to do our Go build again. And if this doesn't work, I may have to restart the Athens. And that would be a bummer. So that error happened because of that 500 error that I hand waved over, which probably can't hand wave over. OK, so now we're cooking. We've got all of our findings done, so we got all of our metadata. And now we're doing our downloading and extracting. I can't talk. So same deal, except this time, Athens had an empty local cache. This is not the disk cache that I was sudo RMing before. This is a cache that Athens maintains inside of that Docker container. So Athens went and pulled a bunch of stuff from GitHub and a couple other VCSs. It filled up its local storage, and then it served those modules back to my Go build. So with that in mind, we've got all of our storage filled up with all of the dependencies that Hugo needs. So let's try this. Let's air gap the computer. Does anyone have aluminum foil we can air gap? No? OK. I'll bring that for the next demo. OK. So now let's see what happens. We've got Athens filled up with modules in its own storage. We've got our disk cache, which I'm going to delete in a second. And we have no more Hugo binary anymore either. Let's throw away that disk cache. OK, so now we saw that failure. And then we saw this, the one that succeeded just now. It took a little bit of time. Let's see if we can get this going a little bit faster. OK, so pretty decent. We're downloading stuff over localhost. That's cool. Finding was not long at all because, again, we've got everything in storage. We were stuck on this last extracting. But overall, this build went pretty darn fast. So why is that? Well, first of all, we're not going to the internet. Second of all, Athens is storing stuff locally inside the Docker container. So that's pretty fast to go access storage. But then third of all, Athens no longer needs to go to the VCS. In fact, it can't. And that's kind of the magic here. Essentially, since Hugo doesn't have a vendor directory, we've got a vendor directory kind of in the cloud. That's kind of cool. So let's explore that a little bit more. And there's a reason why I downloaded the slides onto this PDF. Because last time when I was prepping for this, the Wi-Fi didn't come back on, and Google Slides failed me. So we're going to stick with the PDF. OK, so I'm calling this sort of secret evil plans. These are kind of, we saw the Go build, and the Go build was like kind of cool and kind of boring. A Go build alone is cool because it works and it's a little bit faster. But if you kind of peel that away and look behind the curtains, there's some really exciting stuff going on. And this is applicable to Athens and any other module proxy out there, whether it's out there now or going to be out there in the future. So the first thing is we're solving kind of the works on my machine problem. If you did not have a vendor directory in your project, and you came in at 10 a.m., which is super early for any software developer, so you shouldn't have done that anyway, it's your fault. But you came in at 10 a.m., you did your Go build, and it worked. Yay. But then your colleague came in at a godly hour, not an ungodly hour, maybe 2:30 in the afternoon. And they went and did a Go build on their development machine, and it failed. OK, so this is kind of like I'm going to say, I got here early. Early bird gets the worm. Works on my machine. Shrug, turn around, and leave. OK, but that may have happened. The build failure may have happened because maybe one of the package maintainers decided to do a git push -f or any one of those other problems that I kind of mentioned at the beginning of this talk. But we can go a little bit further than fixing the works on my machine problem. I mentioned that Athens can be kind of a vendor directory in the cloud, and any other proxy can do the same thing. So that's cool because we've got deterministic builds now. But it's also cool because we get these speed ups. I showed the speed up when, in that third Go build, we air-gapped the machine, and we were serving from Athens directly out of local storage down to the Go build. But also, even if we're serving down from the internet, we're not serving Git trees anymore. So we don't have to serve Git history. We don't have to serve like massive assets if they're not necessary. Instead, we're serving these zip files. And zip files are snapshots of just the code at a given version. And they're compressed, obviously. They're zip files. So I took the extreme cases. I think these are two of the biggest 5 Go repositories out there as of 2 weeks ago. And you can see the difference in size, right? These are the biggest response bodies from the module API that you'll see for any given package, for any given module. So I think that's, I'm not good at math either, so maybe that's like 20x or 30x. If you know the exact number, I'll give you stickers. Come talk to me after. But pretty good, especially if you're downloading from a CDN or maybe even not a CDN from a server in the cloud somewhere. But if you're running Athens internally, inside of your VPC maybe, or even on your local machine, this is going to really shine. Because not only if you have to download from the internet, that's going to be faster, but it's going to be lightning fast if you do that kind of thing like I showed in the third demo, where you're serving directly from localhost. Second thing, Athens is built and created, and it's a project that's maintained so that you can run it inside of your enterprise. Who works in an enterprise? Yeah. OK, so that's a real thing. People write Go code inside of companies that are regulated. Might be insurance company, a bank, whatever it may be. And you, as an operator or an IT person, obviously will need functionality to both get dependencies into your code bases, but also to protect yourself against maybe insecure dependencies or licensed dependencies that are incompatible with your org. So Athens has some features that are growing to take care of things like this. It has its own storage, like we've been talking about, so you can audit the packages and modules that you're using. But it can also act as sort of a bastion host. So it can be the server that can talk up to VCSs, and it can exclude various modules that you decide are not compatible with your org. So everyone can point their Go build inside of the org to that one Athens, and Athens can determine whether their Go build should work because they have all the right dependencies that are allowed, or it should not work because Athens says, nope, that's a dependency that we're not going to take on inside of the org. And then also, I kind of hinted at it, but Athens can sit behind firewalls, completely behind firewalls. So you can air gap your organization and your team. And you can have Athens serve up both public and private code. But instead of having Athens go fill up its storage from a VCS, you can instead just load code into Athens storage. You can take a USB stick from your home, bring it over to your org, and plug it in. And then the last piece. This is the one I'm most passionate about. I mentioned the module download API. That's an open API. APIs are pretty cool because if you publish the protocol for the API, anyone can implement it. They can put their own logic behind it, as we all know, and you can build different abstractions. So I call it the lingua franca of the Go module ecosystem. And if you can build a 5 REST API system, server, you can talk to Athens, Athens can talk to you, Athens can talk to some other module proxy, your thing can talk to some other module proxy, and we're all cool, we're all federated across the module ecosystem, and this is a really powerful system. I talked to someone at Gopherpalooza in San Francisco in October of last year, I think, who told me that they built a module proxy in Bash. And I pulled it down, I ran it, and I got Athens to talk to it. So that's kind of cool. Anyone want to build a Bash HTTP server with me another time? Yes. OK. OK, I have a thing that day, so. OK, so we've got these sort of federated systems that can talk to each other, and that's cool. I kind of mentioned you can run your own Athens, so you can kind of control your own modules, control your own destiny, maybe control your own entropy as well. But now we're starting to see that things are being built on top of this API that are not quite concerned with just serving up modules and metadata. For example, I'm going to put Marwan on the spot here. He's sitting right there, so go ask him all the questions. Don't ask me any questions, just him. Just kidding. But Marwan has built sort of, I think, maybe the first extension on top of the module API. It's called moddoc. It ends in doc, so you can probably imagine what it might do. It is a documentation server that instead of crawling the entire internet like Godoc does, it just talks to a module API. And for that module API, it gets documentation, it serves it up in an HTML web page. Sort of similar to what Julie said Google is working on, the Go team is working on. So this is a prototype of that. And it actually worked pretty well. I pointed it to the local Athens that you saw me run. There was a hand-wavy moment, just like we saw. And then after I waved the hand, I ran it again, and it worked. So more things like this are coming. I'm building a really, really terrible crawler that's going to go up and talk to the API and then crawl and download more stuff into the API. Never used that, but it's sort of a proof of concept. So this is sort of the last slide. So I want to just kind of put out a call to action. If you're interested in this kind of stuff, module proxies directly or extensions on top of those things, Marwan, again, putting him on a spot twice in this talk. Bet you didn't know that was happening. So Marwan coined this phrase, chill open source projects FTW. We try to kind of be like that in the Athens community. So we don't ping each other asking for status updates. We're not going to take away your red stapler. You can break all the printers you want in a field somewhere. but I really encourage you to just come check us out. Okay, so there's tons of ways. We're always on the Athens channel in the Slack. Tons of issues for first, sort of good first issues and newcomers in the repo. We're on Twitter. And then I put some fancy marketing logos up here. So people are using Athens. And I'm actually really excited about that. There are real use cases that are talking back to us, giving us sort of new feature requests and bug fixes and so forth. I actually found out the Go team is using Athens to build part of Go. I was pretty excited about that, too. So that's it for me. The slides next to the video icon, that's the closest icon I could get to slides. They're under that short link. All the code for that demo, there's a whole script, and I think there's a makefile in there and so forth under the second one. And I want to credit my wife at Franzia for drawing all of the diagrams to make this talk not terrible, but look really nice. I can confirm that without those diagrams, it's just white slides, and it's not as cool. So thanks to her as well. Obviously, I'll be around for the rest of the day. I have stickers, so even if you don't want to ask questions or talk to me, come to me for stickers. So thank you, everybody.